Hello and welcome to this video on Venn diagrams. Okay, so they all look like this. It's really important that you do a box around the edge, so everything included inside the box, that's like all of your possible things that could happen. And then this is event A, some event, and this is event B. And I'm going to show you what each part means step by step. So firstly, if you want, and so you need to colour these in on the ones on your page 12. So if I want to represent A, that's everything that's in this circle. Okay, B, event B is everything in this circle. Okay, now the union of A and B, so A union B, is basically everything in A or B. So it's all of this stuff. So if A happens or if B happens. Okay, A intersection B is only the bit where A and B are both happening, which is the intersection of these two circles. So this bit in the middle. Okay, A dashed, that means not A, so that is everything that's not in A. That. Okay, not B is everything that's not in B, so everything outside the event B. Okay, or we could have, if it's not A or B, so if it's that means not, so not A or B is everything outside of our two events A and B, so everything in the rest of the box. Okay, and then if we want not A intersection B, then that just means we don't want that bit in the middle, so everything outside that middle slice. Okay, and then we could have A and not B. So these things both need to be true. Where is it true that we have A and not B? So that is this bit here, because we're not in B, but we are in A. So that's where both of those things are true. Okay, now let's do last one. Not A or B. So either one of these things has to be true. So not A is everything outside A, so all of that, and it could or B, so that includes that bit here, because although this bit is A, it's also included in B, so one of these things has to be true for the or condition to work, so it's everything coloured in except that bit there. Okay? Okay, now we're going to look at the addition rule. So basically what I need to tell you first is that Venn diagrams can be used to represent events. So for example, I've got A and B here, they're just events, or it can be used to represent the probability of those events, and that's kind of interchangeable. So here we're talking about the probability of A union B being equal to the probability of A, this bit, plus the probability of B, which is this bit, and then basically we counted this middle bit, we counted it twice, so we've got to take one of them away. So to find the probability of A union B, you add the probability of A to the probability of B, and then you subtract the middle bit. Okay, let's have a go at this question, example 1. So we are going to draw the Venn diagram. So here we are, there's maths, and here's chemistry. So altogether there are 97 students. There are 31 that don't take either thing, so immediately we can fill the outside box in with 31. And then we know that leaves us with 66 people to fill up these three things. And so we know that in total this adds up to 55, and in total this adds up to 32. And if we add 55 and 32, then using the addition rule, that gives us 87. And then using the addition rule, we know that the bit in the middle must be 87 take away 66, because we know that kind of M, U, C equals 66. And we got that M plus C gave us 87. So that means that this middle bit must be 87 take away 66, so this must be 21. That means that this one is going to be 55 take away 21. 34, so that then when we add this and this we get 55 for the whole of that circle. And then the other one is going to be 32 take away 21, which is 11. Okay? Now you have a go at the next one. Example 2. Or no, so maybe it just says have a go. Okay, another lovely Venn diagram, and we're working with probabilities this time. So the first bit is that I've written up the side. So that's the probability of not A and not B and not C is 0.1. So that means in the outer bit of the box we can put 0.1. Now, what else do we know? Okay, we know that the probability of A and B is, so this bit here. Oh, actually, first let's use this. Okay, so the intersection of all of them is 0.1. And now we know that the intersection of A and B is 0.3, so this bit must be 0.2, so that these two add up to give 0.3. Now we know that the probability of A and C is 0.1, so this bit must be 0. What can we use now? Okay, so the probability of A is 0.6, and here we've got 0.2 and 0.1, so altogether we've got 0.3, so we need to get the other 0.3 here. The probability that B happens, well, we don't know this yet. We know that this needs to be 0.3, so what can we use? Okay, we can use the fact that we know this and we know this, and so we can work out the probability of B union C, because these are the only bits that aren't in B union C. So we know that this circle and this circle, their union must be 1, take away this one, take away this one, so that must be 0.6. So if that's 0.6, we know that the probability of B is 0.3 and the probability of C is 0.5 and 0.3, so if we add them together we get 0.8. But actually we want 0.6, so the bit we took away, the intersection, must be 0.2. So this bit must be 0.2, so this bit we can say must be 0.1. And now I can fill in the rest. So this is 0.2, 0.1, 0.1, so that's 0.4, and it's got to add up to 0.5, so this bit is 0.1. And then this one's got to add to 0.3, and so far we've got 0.1 and 0.1, so another 0.1 will take us up to 0.3. Should we check that all adds to 1? So 0.3, 0.5, 0.6, 0.7, 0.8, 0.9. Woohoo!